So I guess we can start by introducing a little bit about ourselves, and then I'll introduce a little bit about the talk series. So this is a talk series that's organized by Jason, Danya, and myself. I'm Chandler. I'm a fifth year PhD student in ECS at MIT, working a little bit on the causal representation learning space, more coming from causal structure learning, and excited to learn more with everybody here. Jason, Danya.
Danya, you go first.
Okay, I'm Danya. I am an assistant professor at the University of Montreal and a core academic member of MILA. I also have been working on causal representation learning, and in my case, coming more from the perspective of classically effect estimation and things like that.
Hi, I'm Jason. I am currently a research scientist at Valence Labs, and will be joining as a faculty member at the University of Waterloo from next year. I also, like Danya, come from a causal effect estimation perspective originally, and then spent most of my postdoc working on causal representation learning with Kartik, who's in this meeting. So, yeah, excited to be here and excited to learn more.
Cool. Well, I won't take too long away because I think it's going to be a really interesting talk today. But just to tell you all a little bit about why we are hosting this talk series, reading group, whatever we'd like to call it. Hopefully everybody can see my screen, right? So, what is this going to be about? We're going to have a kind of broad focus on representation learning, but representation learning methods which target some form of extrapolation or generalization, some ability to give you reasoning about a system in kind of a formal way. And we're going to try to include pretty diverse perspectives on these questions, and kind of as we go, bring together areas that are kind of active fields of research, and not just people coming from causality, but coming from several related areas, and kind of bringing these voices together in a way that we can hopefully kind of build a shared vocabulary together and use that shared vocabulary to enable faster progress, not kind of be unaware about what everybody else is doing in these related spaces, but really sharpen up how we're kind of thinking about these issues. So how is this going to be different from kind of other seminars or reading groups that are out there? Basically, yeah, this scope of what we're going to consider as the purview of this, what kind of representation learning questions we're going to be considering might go a little further than some of the reading groups that are out there on kind of classical causal inference. And we'll kind of be more explicitly focused on the interplay between representation learning and decision making, or kind of these questions about extrapolation, maybe than other reading groups that are focused solely on representation learning. And then before we get started, basically a few house rules about how we're going to take questions and stuff. Of course, Johnny can mention if he has different preferences than this, but the basic idea is that everybody should be staying muted. While staying muted is good, keeping your video on is also good, so it feels like Johnny's actually presenting to a room full of people and not a bunch of blank screens. And then if you want to ask a question, use the chat, and then one of the organizers, or maybe if Johnny sees it, we can call that question out, or you can raise your hand and ask to be called on. And try to keep during the talk kind of clarification questions. So it's the only kinds of things that you're asking, things that you think really need to be addressed before we go on, and save more open-ended questions for the end. So basically, we're going to begin with a short 5-minute discussion by Jason. He'll tell you a little bit about the idea behind even beginning with that, and roughly 45 minutes. So we should have 5-10 minutes for the talk, or for questions at the end. Yeah, Jason, take it away. Jason, you're muted.
I am muted. Good. Okay, so trying to kind of cover this, we are planning to have a pretty diverse perspective on representation learning, and kind of when you cover a lot of different perspectives, it's easy to kind of end up with everything getting kind of diffuse and unstructured. And so we wanted to have a discussant to try and help us maintain context as we veer further away from causal representation learning. We'll start off with causal representation learning, but as topics get more diffuse, we want to make sure we kind of keep some sort of focus. And so the role of the discussant is going to be, in every talk, is going to be to sort of try and sort of say, how does this work fit into a causal representation learning perspective? Obviously, as we drift further away from core causal representation learning kind of analogies, on this discussant slide, we'll get a little bit more loose, and we kind of think that's okay, right? We think that it's still going to be helpful to ground the discussion and keep some sort of focus and see how things fit together. So kind of a common theme in causal representation learning, or much of causal representation learning for the last couple of years has been, we have some distributional assumption on a set of latent variables Z, and then we have high dimensional observations X, which are generated via some mixing function or some rendering function G that maps Z to the observations X. And so we chose Johnny to give the first talk in this space because I think his work is really nice in that it shows kind of in a very precise way how assumptions on the latent Z, and assumptions, the sort of intersection of assumptions on the way assumptions on latent Z constrain the representations we can learn, and assumptions on G constrain the representations we can learn. And the intersection of those two sets of indeterminacies gives you your final identification result. And then the second point that they push, which I think is really nice, is that the tasks that we're aiming to solve should inform what set of indeterminacies we're shooting for. And so I think this gives a nice conceptual framework in which to understand the first set of talks that we're going to be looking at, and especially in the sort of context of causal representation learning. So